Security researcher at Tenable, where he specializes in application and web security. His talk today will showcase a key concept, sometimes not discussed enough. Cloud services are built on top of each other, and one click in the console can cause many things to happen behind the scenes, which increases risks and attack surface. The title of Liv's talk is One Click, 6 Services, Abusing the Dangerous Multi-Service Orchestration Pattern. Please welcome Liv.
Thank you, Mike. Hello, everyone, and welcome to my talk, One Click, 6 Services, Abusing the Dangerous Multi-Service Orchestration Pattern. Cloud providers often build their services on top of each other. It creates risks for defenders and also opens the door for attackers. If one service gets attacked or is vulnerable, the other services are prone to be impacted as well as a result of this Jenga concept that I realized that is actually present in the major cloud providers and not only in GCP. But in GCP, I have a case study for you for today to prove the Jenga concept. So let's get it started. Have you ever pondered with the question of what is going on when you create a cloud function in GCP? So I had, and as an ordinary user or as a researcher, I just created a cloud function in my account. Then I looked at the logs and I saw this odd cloud build trigger that was initiated in my account. Turns out that this cloud build trigger was created by the cloud function I just created. And not only that cloud build trigger, also a storage bucket, an Artifact Registry, or a Container Registry, and possibly Eventarc triggers and a Cloud Run service. All of these services were created for the functions deployment process in order to even create the function I just created in my account. And that is absolutely crazy in terms of attacking privilege escalations, vulnerabilities, and even hidden services that the cloud provider itself, in that case GCP, creates behind the scenes for the user, kind of without the user's knowledge. I am Liv Matan, a senior security researcher at Tenable. I am Microsoft's most valuable researcher, and as you can see or might assume, I hunt across the major cloud providers, and this is the case study of GCP. So we've talked about the Jenga concept, and we've talked about a little bit cloud function and how does it work behind the scenes. But there are some risks correlated. For example, if you think about it, behind every service that you see on the screen, there is more IAM correlated. So these services need to communicate with each other, and sometimes they are attached with permissions. So for example, an attacker with an access to a Cloud Run service, and that Cloud Run service by default have access to the Artifact Registry or a Container Registry service, and these services by default also holds the images of the functions in the same account. So this is just one example of a privilege escalation path that an attacker can abuse as a result of the realization of the Jenga concept. But how does this magic even happen? Like how do these services even communicate with each other? So please welcome service agents. Service agents are service accounts, but they sit in a Google managed service, in a Google managed project. So they're kind of hidden, like you don't really see them because they are in a Google managed project. And this is the Google Cloud Function service agent. So now you can guess that this exact service agent might be responsible for creating all of the resources that you saw that are created when you create a cloud function. This is internal in the Google managed project. It also leads me to another concept that cloud providers often try to empower their capabilities, their usability, and as a result, it leads to more complexity. That better performance leads to complexity, and complexity, as we all know, leads to more risks. For example, second-gen cloud functions. So we have the first-gen, and then Google introduced second-gen cloud functions that includes into the mix these two beautiful services named Cloud Run and Eventarc. So these services are also combined into the mix when you deploy a cloud function. And just imagine what attackers can do when all of these services are included into the mix. That is absolutely crazy. So just so we'll be on the same page, first-gen Cloud Functions deploy these 4 services, bucket, cloud build, and then an Artifact Registry or a Container Registry, and obviously a Cloud Function. And when you deploy a second-gen Cloud Functions, also Eventarc triggers and Cloud Run are included into the mix. So at the end of the day, when you create just one Cloud Function in your account, maybe you will have 6 services in your account. So let's dive into the function deployment flow. So you know these services are created behind the scenes. Why they're even created? Why are they there, right? Well, the bucket, as you might assume, is there to hold the function's code. The Artifact Registry is there to hold the function's image, and the Cloud Build is there to build the function. The Cloud Run is there to run the function. Well, it all makes sense. This is rather simple, right? Well, it gets complicated because, as we said before, every service and each service needs IAM to communicate, and now these services need to communicate with each other in order to deploy the function. So Google has decided to attach this default Cloud Build service account to the Cloud Build service when a user creates a Cloud Function. So when a user creates a Cloud Function, by default, Google behind the scenes also attaches this default Cloud Build service account. And as we all know, defaults are dangerous. You ask yourselves, why they attach the service account? Well, in order to allow the Cloud Build to push the image of the function to the Artifact Registry. Again, this all makes sense. This is how the function deployment works. But how can we even abuse it? Allow me to introduce you to a new privilege escalation vulnerability I dubbed Confused Function. Confused Function vulnerability allows an identity with a permission to update or create a Cloud Function to escalate privileges to this default Cloud Build service account that Google attaches behind the scenes I just presented to you. I'm sure you cannot see it from far away, all the permissions of the default Cloud Build service account, but trust me, between me and you, it includes a lot of permissions. Some of them includes permissions to storage, Artifact Registry, bucket, logs, etc. Absolutely crazy. So let's dive into the vulnerability. Let's do the fun stuff. First, this is an example of a Node.js Cloud Function. Just keep in mind that the vulnerability affects all of the programming languages if you follow the following concept. So an attacker specifies a malicious dependency into the package.json file of a Node.js Cloud Function. And then the package.json file with the other files of the functions will be stored in a bucket. This bucket was created by Google, I remind you. Then the Cloud Build instance that was also created by Google will install these packages. Some of them is the package, the malicious package of the attacker that was just inserted by the attacker's ability to edit the package.json file. So just with an update permission on the files of the functions, the attacker can insert a malicious dependency. Then at the end of the day, when the function is deployed and created, the Cloud Build will install the dependencies of the functions, and some of them will be malicious by the attacker. Then this beautiful Cloud Build default service account will get into the picture, and yeah, the code will run, and the attacker can exfiltrate the token of this default Cloud Build service account that, I remind you, Google has attached behind the scenes. So this is the vulnerability, and it gets even more interesting. GCP dangerous defaults. GCP, and in that case, used the defaults. They use the defaults for the user configuration of the function's deployment. They use the default Cloud Build service account, and we all know that defaults are dangerous. So this is one takeaway for this presentation. And another takeaway is that this is an hard-to-fix vulnerability. This architecture, as I just showed you, needs all these permissions. For example, the Cloud Build is there to push the image. So it has to have the permission, the service account has to have the permission to push the image to the Artifact Registry service. The fix that Google proposed is to now allow user to choose the custom Cloud Build service account. So before the fix, the user didn't have any visibility to that Cloud Build service account that is a part of the function's deployment process. But now, when a user creates a cloud function, it can choose two service accounts. One is the service account of the cloud function's runtime environment, and the second one is the service account of the Cloudbit instance that is created with the cloud function. And Google also decided to use the Compute Engine service account as a new default for new cloud builds. We can infer that as a result of the fix, or not as a result, but after this fix, still old cloud builds are vulnerable because the fix applies to new cloud builds. Google has decided to deploy the fix by using a new organization policy that you can utilize after Google has deployed the fix. And this allows to disable the creation of the default Cloudbit service account we have talked about. Some thoughts on the fix is that there are still minimum permissions for that custom Cloudbit service account to work. These are the minimum permissions that you see on the screen, and they are also documented in Google's documentation. Some of them, as said, are Artifact Registry writer and also storage object admin, which are relatively very high permissions. So still, the vulnerability lives to some extent because the user has to deploy these permissions to the custom Cloudbit service account. Also, we all know that the Compute Engine default service account is notorious for being overprivileged, so this is still kind of risky. A little bit about the security architecture of AWS Lambda with buckets, the equivalent of Cloud Function in GCP, is that in AWS we see an interesting thing as opposed to GCP Cloud Function. The function's code in AWS is stored in an AWS managed account, as opposed to GCP, that the code is stored in the user's bucket. And if we talk about the shared responsibility model, this is kind of interesting because in AWS case, the responsibility is on the cloud provider side because it's an AWS managed account, and in GCP, the bucket is stored in the user's account. So the responsibility is on the user side. So just so you can think about it more deeply and decide what you want to use. If we dive deep into the bigger picture of privilege escalations, we can see some interesting stuff. Is that an attacker with a permission to Cloud Run service can do that interesting following scenario. So, Cloud Function, then an attacker with access to a Cloud Run, the scenario we have talked about. Cloud Run, I remind you, is a service that is created when you create a second-gen Cloud Function. So, an attacker has only access to Cloud Run. He doesn't have any access to a Cloud Function, and that Cloud Run by default pulls the function's image from an artifact or a container registry. Now, when you think about it, we said that services need identities to communicate with each other. So in that case, Google has decided to use the Cloud Function service agent in order to allow the Cloud Run to pull the images. So as an attacker, I observed the request and I saw that the Cloud Run service is deployed as follows by the GCF admin robot, which stands for the Cloud Function Service Agent. So the next step for me is to actually abuse it. How will I abuse it? The Cloud Function Service Agent is the one that is responsible for pulling, so I can just specify the image that I want to pull. For example, an image of another function in the same account, another function, and I don't need to have any permission to the function. I need to only have a permission to the Cloud Run, and the Cloud Run will do the job for me with the Cloud Function Service Agent. This is how it looks like in the GCP console. So you can see, you select a container image. Obviously, in that case, I had a read permission to the names of the container images, but you can also guess the container image name, and you can simply abuse the Cloud Function Service Agent in order to pull any function's image. That is absolutely interesting. About storage access, there is a bucket, and that bucket is created when you create a Cloud Function, and in the bucket you can see Cloud Functions code. So another privilege escalation path you can utilize. And in the Cloud Functions code, you can often see secrets or vulnerable code. So this is another privilege escalation path that you can utilize as a result of the Jenga concept, that a bucket is created when you just create a Cloud Function. I'm going to reveal to you a new tool, and as researchers, you can use this tool to map the hidden services that are created by the cloud provider behind the scenes this is a specific example of AWS, but keep in mind we're going to expand the tool to also be applicable to GCP and Azure. And this tool helps to combat the Jenga concept. The Jenga concept that hidden services are created behind the scenes, you can combat it with the Jenganizer. So what it does is basically maps the hidden services that are created behind the scenes by searching the logs, by inspecting the logs. And I'm going to give you a live demo of this tool. Hopefully my hotspot will not break the demo, but let's pray together. So I'm connected to the hotspot, and as you can see, this is the tool. I specify my username, the profile name, the region name, and also I specify a time start and time end to specify the specific. Oh, you can see it. Sorry. Let's see. Yeah, there we go. Woo-hoo. So, I specify these parameters. And I also specify a time start and time end, so I can inspect the specific action I just made. So I run the tool, and as you can see, it runs. And this is an example of a CloudFormation create stack, and as you can see, this is just an example. Obviously, I wouldn't use it as a great example if I was an attacker, but you can use it, and you can see it created the EC2 run instances, create tags, all of these actions that were created, that were created as a result of the CloudFormation creation stack. This is depth level 1. Depth level 2 will also look for the actions that this EC2 that was created did. And also you have depth level 3 that will also recursively check the next service. So a great tool you can use to utilize and map the hidden services that AWS creates behind the scenes as a result of a creation of a service. In GCP, you can use this following query. The following query searches for creation of services. This is search, parentheses, created or creation. And after you search it with this following query, you can see this is an example of a cloud function, and I can see that a cloud build and a GCS bucket were created as a result. So, vulnerability patterns in the cloud, we're going to wrap up. We can say that one click in the console makes the cloud provider configure a vulnerable deployment to the user. It happened in GCP, but this is just one example of a cloud provider. We also have research on AWS and Azure that we can't reveal today, that also the same scenario happened. So keep in mind, what do you do when you create a service in the cloud provider, and also you can use the Jenganizer tool to help you map these hidden services that are created and the vulnerable configurations that are created when you create just one service in the cloud provider. Even the cloud providers themselves get it wrong sometimes. For example, in that case, GCP use defaults, and that's okay. They all get it wrong sometimes. Cloud providers are not bulletproof. This is another takeaway for the talk. We reported a vulnerability to Google, which remediated the vulnerability, awarded a bounty for it, and please comply with the bug bounty rules because the research and collaborative and the community is very helpful and we need it. As for the shared responsibility model, keep in mind these services, the hidden services that we have talked about, are services that are in your account. So you're responsible for them. You can edit them, you can see them, and you can delete them. So keep in mind to map the hidden services because cloud providers sometimes can be a black box. Thank you.